All right, good morning, everybody. This is the statistics questions, part one. Let's just get right into it, right? Please be careful how you're reading the questions. So, first of all, a class of 30 students counted the number of books in their bags on a certain day. The number of books in each bag is shown below. So I can see I have a whole bunch of numbers here representing the number of books. Now, one of the things that you have to do in statistics is to simply analyze data, and that is what they're testing here, how you can analyze these numbers, right? So copy and complete the frequency table for the data shown above. Immediately I'm noticing something. I'm noticing that, well, they have frequency, but they also have the F times X. That is the F, and this is the X. And so, immediately I could kind of tell that we're probably going to have to use the formula for mean. So the formula for mean being, the mean is the summation of Fx all over the summation of F. So we are probably going to have to be using that formula at some point in time, right? All right. So we could see here that the number of books, so the number of students here, 2 students had 1 book in their bag. So let me check that. I could see that 2 students had 1 book in their bag. Am I seeing 1 anywhere else? No, I'm not. Yeah. I could see that 3 students had 2 books in their bag. So I'm expecting to see 2 books 3 times. All right. So yeah. Now, how many students have 3 books in their bag? And you notice how I'm crossing out the numbers. That's to make sure that I don't count them again. I want to make sure that I can see what's the numbers that I have left. So how many students have 3 books? 1, 2, 3, 4, 5. So we have 5 students. And with a tally, we go 1, 2, 3, 4, and the 5 goes across like that. And then we just write the number here, 5. So that's how we write a tally. Number of people with 4 books in their bag. Well, let's see. 1, 2, 3, 4, 5, 6. So apparently we have 6 people with 4 books in the bag, I would hope. So how we write that in a tally? 1, 2, 3, 4, 5, 6. And that's 6 people. The amount of people with 5 books in their bag would be 1, 2, 3, 4, 5, 6, 7. Any others? No. So 1, 2, 3, 4, 5, 6, 7. 7 people. The amount of people with 6 books in their bag would be 1, 2, 3, 4. So that's 4 people. The amount of people with 7 books in their bag would be 1, 2, 3. That's 3 people. Now, if we add up this, we are supposed to get 30 students, because remember, these are the amount of students, right? So if we add the frequency up, we should get 30. So that's one way to check to make sure if you got everybody. I forgot to put the tally for 3. So if we add them up using our calculators, 2 plus 3 plus 5 plus 6 plus 7 plus 4 plus 3 equals 30. Yep, and it's always good to just check it over just to make sure that you got all of the numbers, right? And so now we just have to do the calculation for the fx column, and that is where we take this f and multiply it by this x. So 2 multiplied by 1 is what gave us 2, and then 3 multiplied by 2 is what gave us 6. 5 3s are 15. 6 4s are 24. 7 5s are 35. 6 4s are 24 again. And 7 3s are 21, I believe. And you know how great I am at my timetables. So state the modal number of books in the bags of the sample of students. So the modal number is the one that's the most popular, which is the one that has the highest frequency. So we could see that the highest frequency here is 7. And so therefore 5 books, 7 students had 5 books, and that is the mode. So that is the most amount. So the modal number of books would be 5 books. That is the one that most of the people had 5 books in terms of 7 students, the one with the highest frequency, right? Using the table above or otherwise, calculate the total number of books. So think about it, right? If 2 students had 1 book, then 2 times 1, that is 2 books there. If 3 students had 2 books, then 3 2s are 6, that is 6 books there. If 5 students had 3 books, then 5 3s are 15, so that is 15 books there. So if I add up this column, what I'll actually be getting is the total number of books, yeah? And so we adding up that column too. So the total number of books brings us to 127 books in total, yeah? Another way would have been for us to add up all of these numbers, but that way would have been a little more painful, So this way was a little easier. The mean number of books per bag, well, I know they would have asked me for mean, right? So we know the total here is 30, and we know the total here is 127. So the mean is the summation or the total of the fx column all over the summation or the total of the f column. So that is simply 127 divided by 30. 127 divided by 30 gives us about 4.2 books, if we keep it to 1 decimal place. So the mean or average number of books is around 4.2 books. Around 4. Determine the probability that a student chosen at random has less than 4 books in his or her bag. So how many students, because we have, remember, the probability of a student having less than 4 books. That is the favorable outcomes, which is the ones that we want, which are those students who have less than 4 books over the total amount. We know the total amount of students is 30 students, right? So determine the probability that a student, the students we're looking at, a student, so we have 30 students in total. Let's see the favorable outcomes. The favorable outcomes meaning the students that have less than 4 books, right? And notice they have less than 4 in big capital letters. So that means that they really mean less than. They don't mean less than or equal to. That is why they have it in capital letters, because they want to know that, they want you to know it's less than. So it's less than 4 books. So that means that I'm not going to count this 4 books column, because I want less than 4 books. So that will be 3 books, 2 books, and 1 book. So how many students have that? That is 5, 6, 7, 8, 9, 10. So 10 students have less than 4 books. And so we could see the probability is 1 in 3. that we could choose somebody at random and they will have less than 4 votes. So now let's look at this other one, the second question here. And you notice how this is also a number 7. So in the paper 2, your number 7 or around there, 5, 6, 7 is usually where your statistics question is, right? So copy and complete the table below. So the table shows the ages to the nearest year, all right, of the persons who visited a clinic during a particular week. So I see in the amount of people who were between 40 and 49 is 4 people. The amount of people who are between 50 and 59, we have our class intervals here. What we need to do is complete this cumulative frequency table. So we can see here that 11 plus 4 gives us 15. Right? And so this first table here, this one will be all of the people who are less than 49 years, all of the people who are less than 59 years, I'll put it on this side. Less than 59 years will be the 11 plus the 4, and then less than 69, less than 79, and less than 89. Well, we could see that the cumulative frequency gives us the total, so it's really 50 people in all, right? So what I would need to do is take this 15 and add it to the 20. So 15 plus 20 is 35 over here. And I would have to take the 35 and add it to the 12, and that would give us 47 over here, and then 47 plus 3 will give us the 50 there, so we know that we're okay with that. That's 2 marks. Ooh, we have to draw a graph using a scale of 2 centimeters to represent 10 years on the x-axis. The x-axis is the horizontal. And you know we usually put frequency, and frequency is the number of people, right? So using 1 centimeter to represent 5 persons on the y-axis, draw the cumulative frequency curve for the data. All right, so that should be easy enough. Remember these things, this less than 49 needs to be less than or equal to 49, right? Less than or equal to 59, less than or equal to 69, and so on, right? Because this is what we're going to be putting on our vertical or on our horizontal axis, right? So this is the horizontal axis here, and these numbers will be the vertical axis here for the cumulative frequency curve, right? So what they say on the horizontal axis, they want 2 centimeters to represent 10 years, right? So I'll have, you can see the range starts from less than 49, 2 centimeters here, and that gives me less than 49. Over here we'll have less than 59. Over here we'll have less than 69, less than 79, and less than 89. And on the vertical axis, 1 centimeter represents 5 years, so 5, 10, 15, 20, 25, 30, 35, 40, 45, and well, I just ran out of space there, so let me just see if I could fix that. Right, so I have a little more space there, so now I could put my 50 up here. This, remember to always label. So this is cumulative frequency, and these here are your ages. And so let's plot this thing now, right? So I see in here that, and I'll just do it in a color that will stand out, but you please don't use, you should only use black or blue for any exam, no other colors, right? I'll use black, I'll stick to black for safety sake. So 49, so less than 49 we have 4 students. So 1, 2, 3, 4, 5. So let's put 4 students at about there. 59 students should be around 15 students here. 69 students should be 35 students here. 79 years should be 47 students, so we'll put 47 students about there. Just do that over. And then 89 students goes to the 50, so 50 will be here. And this is what our cumulative frequency curve looks like, and you do have to draw as smooth of a curve as you can. I'm gonna try to draw it as smooth as I can on this tablet here. It's not very easy. All right, let me see if I can get it a little smoother than that. So use your graph drawn above to estimate. They use the word estimate because not everybody will draw a smooth curve. You know, some people's curves might be a little smoother than others. And so they use the word estimate because they know that everybody's answer might just be a little bit different. Yeah, you wouldn't be wildly different, but you might get slightly different answers depending on how your curve turned out, right? So use your graph above to estimate the median age. So the median age, when we know we calculate a median for a cumulative frequency, median being Q2, for cumulative frequency is just a half of the nth person, right? So that is that we have 50 people, so a half of 50 gives us the 25th person. So the 25th person, well, if we go here in the cumulative frequency table, we can see the 25th person falls somewhere inside of here, but we're not exactly sure where. You know, we can't really get a median age because, you know, in this side we have less than 69 and here between 60 and 69. So we know they're between 60 and 69, but, you know, we need a median age. We need an actual age. We don't want a range of ages. So that is where we go to the graph. So on the graph is where we will find the 25th person. And from the 25th person, I will cut a line. So this is the 25th person here. Cut a line across to meet my curve. You see my curve meets exactly at that point there. And I could come down like this. And so we could see that, you know, 59 to 69. And this is kind of halfway through. So this would be 59 plus 5, about 64. And as I said, it's an estimate, so maybe you would have gotten 63 or you could have gotten 65. It's an estimate, so if you got around 64 or 63 or 65, depending on your curve, all of those should be, but you shouldn't get something that's too far away. So if you got 74, well then that would be wrong. So once you got around 64, then the median age would be approximately, and this is the sign for approximately, 64 years. The probability that a person who visited the clinic was 75 years or younger. So the probability that a person visit the clinic was 75 years or younger. So 75 years is maybe around here. And I'll do this in green, even though you should never use, I'm only using these colors here so that you guys could see it properly. Please never use red ink on your graphs or anywhere on your paper. Red ink is for the instructors only. Never use green or purple, only use blue or black. All right, only blue or black, please. But I'll come here with green just so that you could see it a little clearly. 75 should be around here, so let's just go up with this line. 75 years, and we could see when we cut across here, I could let's call that about 44 people. So let's just say around 44 people, right, are less than 75 years old. Right, 75 years or younger. So what is the probability of getting somebody who is less than 75 years? Well, that would be the 44 people. All of these people are less than 75 years. This entire range here, you know, this is your 75 years here. All of this is less than 75. So that means all of this will be less than 75 years old, and that's 44 people. So 44 is the favorable amount over the total amount of 50. So we can see that 44 divided by 50 gives us 0.88, which is very, very close to the, very, very close to 1. So it is highly probable that if you choose somebody at random, they will be 75 years or less. And of course, they say here to draw the lines on your graph to show how these estimates were obtained. And yes, the lines are there. Of course, you didn't have to do the shading. It's not the shading that they're looking for. Oops, I erased my thing. It was just those lines, the red line and the green line. That is what they will be looking for. All right, moving on, we have another graph question here. So I could see here that we have 6 years and the amount that were produced. On the graph provided, draw a bar chart to represent the data given in the table above using a scale of, all right, so let me see what scale here. The scale of 1 centimeter to represent 1 year on the X or the horizontal axis, right? So 1 centimeter to represent 1 year. Now remember, this is 6 years I have. This is not a histogram. This is a bar chart. So the bars do not need to be joined. And so on our graph paper here, we can have, a bar here for 2010. This is 1 centimeter here. So let's put 2010 here, 2011 here, 2012 here, 2013, 2014, 2015, and 2016. Well, we only need up to 2015, so at least we have enough place. And then on the y-axis, they say use 1 centimeter to represent 25 tons. The question did say to use 1 centimeter, which is one of these, to represent 25 tons. So one of these represents 25, 50. So that means that I'll have 100 here. And that means that I'll have 200 here. So yeah, I might be able to fit it all. Sure. All right, let me try it. Let's see. So if this will be 25, this will be 50, this will be 75, this will be 100, 125, 150, 175, 200, and then 225. Yes, thankfully everything fit. So now let's plot this graph. Here we have 2010. The year 2010, we have about 150. So the year 2010, and as I say, I will just, all right, let me use black. The year 2010, we're reaching 150 there. So this will be the bar. And I don't have a ruler, so I have to draw it freehand. This software doesn't really have a ruler here, but that is the bar for 2010. You please use a ruler. 2011, we go up to 275, so we need up to 300 here. Oh, okay. Well, I don't have space for that, really. So what I will do, you should have space on your graph paper. You should have space, but I don't have space, so I will just calibrate mine a little bit different, right? But what you saw there is how they want you to calibrate it, with 25 tons for every 1 centimeter. I'm gonna use 50, right? So 50, 100, 150, 200, 250, and then 300. Yeah. So my graph might be a little bit different from yours, but my graph paper, your graph paper should definitely have it though. And so we have 2010 being 150, so my graph will be a little bit smaller. 2011 being 275, so 275 will be right here. Alright, I have my bar chart. I hope yours is neater than mine. Remember, I did use a different scale because of my idiotic graph paper. But I did show you the correct scale before. Determine the range of the number of bananas produced. Well, the range will be from 40 tons to 275 tons. And that'll be our range, right? During which year was the greatest production of bananas? Well, I mean, you could see it on the graph, you could even see it in the table. You don't really even need the graph to see that, but we could definitely see that 2011 had the greatest number. How is this information shown in the bar graph? By the highest bar. Between which 2 consecutive years was there the greatest change in the production of bananas? Well, I could see on the bar graph that would be 2011 to 2012 having the greatest difference in the heights of the bar. Right, so the greatest change would be 2011 to 2012. How is this information shown on the graph? Well, it's the biggest difference. In the heights of the bars from 2011 to 2012. Easy peasy question. Nice and easy. I hope I'll get a question like this for the exam. Give one reason why the bar chart is suitable for predicting, or give one reason why it's unsuitable for predicting the number of bananas produced in 2016. Well, a bar graph is only used to show a bar graph. Shows summary statistics. So it's just used to summarize data, and it cannot be used to predict data. Remember, a bar graph is not something that you will want to get like your mean or your average, and you can't really get certain information from a bar graph. It's an oversimplification of important data. You can't get distribution, like how we talked about normal distribution curve and how you could get outliers and that kind of thing. And these things could probably be used predictively, but the bar graph it's not. There's no way to tell. It's just to be used to summarize the statistics. Yeah. Okay, so we have some multiple choice questions here now, and we see that we have a pie chart. So item number 45 refers to the following pie chart, which shows the drinks preferred by groups of students, right? AOC is the diameter of the circle. The diameter, AOC, O would be the center, and the diameter is the straight line running through the center. So AOC is the diameter, and the important thing to know about the diameter is that it is a straight line, and the angles on a straight line is 180 degrees. So that is one thing that we would need to know from geometry for this question, right? 180 degrees being a half of the full circle, yeah? So, if 12 students preferred lemonade, so 12 students here preferred lemonade, then the total number of students is what? Well, if 12 students preferred lemonade, I could get the amount of the angle for this. The angle for that would be the 180 degrees minus 120, and that would give us 60 degrees. So we have a 60 degree angle here, and so 60 degrees is equal to 12 people, because 12 students prefer lemonade. So 12 students is 60 degrees. So therefore 1 degree will be 12 on 60. You divide both sides by 60. And so therefore 100 degrees, which is the total. No, not 100. What's wrong with me, boy? I'm thinking about 100%. No, not 100 degrees at all. It's 360 degrees, which is the total. Will be the 12 over 60 multiplied by 360 over 1. These zeros will cancel. 6 into 6 is 1. 6 into 6 is 2. 6 into 12, is 2. And 36, we have 36 times 2, which will give us 72. So we have 72 total students, B. Alright, so in a class of 20 students, 12 are girls. So these are total students, and these are the girls, right? 12. What is the probability that a student chosen at random is a boy? So if it has 12 girls, so total is 20. If the girls is 12, then the boys will be 8. And 12 and 8 is 20. And so what's the probability of choosing a boy at random would be the favorable outcome. So the probability of choosing a boy would be what we want is the favorable outcome, that is the boys, number of boys over the total possible outcomes. And so that would be the 8 boys over the 20 students. They didn't even reduce it. The pie chart below, another pie chart here, drawn to scale. Drawn to scale, that's quite interesting. Usually they wouldn't specify that. Shows how a student used 12 hours in studying English, math, French, geometry. English, math, French, geography, The amount of time spent studying mathematics is approximately, so 12 hours. Now we could tell maths looking 90 degrees-ish. Unless they give us an indication that it is 90 degrees, we could never just assume. We could never assume that it is. But it is looking 90 degrees-ish. It might be 89 degrees. It might be 91 degrees. That is why they have this big approximately here. So if the 360 degrees or the full circle represents 12 hours, then 12 divided by 4, this is the full circle that represents 12, and let's divide it by 4. So 4 3s are 12. So each quadrant would represent 3 hours. And therefore since this looks like it's 90 degrees, it looks like it's about a quarter, it would represent one of those 3 hours. Each of the letters of the word chant is written on a slip of paper similar in size and shape. Alright. Each of the letters of the word chant. The slips of paper are then placed in the bag and the bag is thoroughly shaken. What is the probability of drawing a letter C? So we could see here that we have 2 C's. Alright, so the probability of drawing a C is the favorable outcome, which is 2 C's, all over the total possible outcomes of 1, 2, 3, 4, 5, 6. Total outcomes. And so we can see here 2 over 6 will give us 1 over 3, 8. Jada's scores on her 9 spelling tests are all of that. Therefore, her median score on these 9 tests is. So Jada's scores on her 9 spelling tests are these. Therefore, her median score on the 9 tests are. Median is the number in the middle, but we need to put it in ascending order. 4, 4. Then we have 5, 5. Then we have 6, 6. And 7, 7, 7. How many numbers is this? It's 1, 2, 3, 4 on this side. 1, 2, 3, 4 on this side. The median being the one in the middle. 6. If the mean of the 4 numbers is this, if the mean of the 4 numbers 4, 8, x, and 12 is 10, then what is x? Well, we know mean is when you add the numbers up, 4 plus 8 plus x, and then 12, so that's plus 12, divided by the number of numbers, so that's 4, and that will give us 10. So now, we just do the algebra here. We have 4 plus 8 plus 12. I can just add those things. So that's 24, right? 4 plus 8 plus 12 is 24. So what we really have here is we really have 24 plus x all over 4 is equal to 10. I could throw across the 4 to give us 24 plus x is equal to 40. That's 10 multiplied by 4. X will be 40 minus 24. So 40 minus 24 gives us 16. The boundaries of the class interval, remember the boundaries would be 0.5 below, so that would be 9.5, and 0.5 above, that will be 14.5, right? Our best recorded as, so we have, this one has the 9.5 and the 14.5, and yes, we could see that the lower boundary here will be taken to be in this class. The upper boundary will not, because remember the upper boundary is really the lower boundary of the next class, right? So this class really goes up until 14.4, you can see. So the boundary in the middle of two classes will always be considered to be the lower boundary of the next class. and so it would be C. You include the 9.5, you don't include the 14.5. It is, however, the only answer that has 9.5 and 14.5. So refer to the following histogram, which shows the number of children aged 4, 5, 6, 7, and 8 who took part in a survey. You can see the ages here. And these are the number of children or the frequency. What is the modal age? Well, the modal age will be the one with the highest frequency. So that is 7. Right? The highest frequency is 7. That is 5, sorry. And so that tells me that 5 children have 7 years of age. And so that is the most amount of children here is 7 years of age. So you can see they put 5 there just in case you put this number. No, it's not that number. It's always on the horizontal range. How many children took part in the survey? Well, we could just add this up. You see, we can have 3 children here, 4 kids here, that's 7, 8, 9. I have 1 is 10, and then I have 5 here, 15. So 15 students. Item 44 refers to the following pie chart. So we have a pie chart here. The pie chart above shows how 100 children spend their leisure time. So 360 degrees is equal to 100. That's the first thing that I'm thinking about. The number of children who use their leisure time for games is approximately, well, they say approximately here. So this is 90 degrees. So that is a quarter, right? A quarter of 100 will be 25. This 90 degrees here, that will be 25. So that means a half of the 100 will be 50. That's this whole area. So this number will be somewhere between the 25 and the 50. Are there anything here between 25 and 50? 40. That's the only thing between 25 and 50. So it had to be 40. Tony obtained the following scores in a game. So these are the scores. He obtained the median score is, and of course we'll need to put this stuff in ascending order. 3. We have 1, 4. We have a 5. 1, 5. Notice how I'm crossing out the numbers. We have 1, 6. We have 1, 7. We have 2, 8. And we have 2, 9. And so I can see here if I have 4 on this side and 4 on this side, the number in the very middle is 7. The median is the one in the middle. So we have a question here. The bar chart shows the number of students who bought different numbers of books. So these are the number of books here. We have 3 books. How many students bought 3 books? 8 students bought 3 books, right? So how many students bought exactly 4 books? Well, we could see here is between 8 and 10, so it had to be 9. Now, what is the mode of the distribution? The mode of the distribution is the one that's most popular, being the most amount of people. And we can see 14 people had 5 books. So the answer is 5 books. 5 books has the most amount of people. So the following scores were obtained by 11 footballers in a goal shoot competition. What is the mode? The mode is the most popular, or the one that has occurred the most. So how many 5s do we have? We have just 1 5. To me, 8 looks like the mode because 8, we have 2 8s. We have also 2 3s as well. No, 1, 2, 3, 4 3s. So four 3s will definitely make 3 the mode for sure. Because that is the most amount of times that we get. The most frequent number there is 3. And the final question here is a paper 2 question. The information below represents the minimum temperatures in degrees Celsius recorded in a country A for the first 20 days in a particular month. So alright, so these are the minimum temperatures in some country over 20 days. So I should expect 20 items here. Complete the frequency table below using the information above. So you can see I have a tally, I have a frequency. So for example, on one day, we had our temperature of 21 degrees. On 22 degrees, there, that is one day as well. Notice how I'm crossing off the numbers to make sure I don't duplicate. So 23 or 24 degrees on 3 days. So let me find the 324s. There. Right, so let me see. 23 degrees. We have 1, 2, 3, 4, 5. So 5. 1, 2, 3, 4, 5 is how you write a tally. And then that's 5 here. 25 degrees will be 1, 2, 3, 4, 5, 6, 7, 8. So we write 1, 2, 3, 4, 5, 6, 7, 8. 8 is the tally there. And then 26 degrees is 1, 2. 26 degrees is determine the median. The median in a frequency distribution. Okay, so for the median, I'm going to need to find the cumulative frequency. So I'll put a cumulative frequency part here. And that will be 1. 1 plus 1 is 2. Plus 5 is 7. Plus 3 is 10. Plus 8 is 18. Plus 2 is 20. So I have my 20 days. And so once I have that cumulative frequency, I come with Q2 being a half of n plus 1, the n plus 1th day. So that is a half of 21. 20 plus 1. So 21 divided by 2 is 10.5. So the 10.5th day, right? So the 10.5th day, that means that the median is between the 10th day and the 11th day, right? So if I come here, I can see that my 10th day is 24 degrees. So 24 degrees is one of them, but then my 11th day going to fall in here for 25 degrees. And so I have two medians, 24 plus 25 divided by 2. 24 plus 25 divided by 2 is 24.5. So we know mean when it comes to this kind of thing is for a frequency distribution of ungrouped data is the summation of fx all over the summation of f. So I know the summation of f from the cumulative frequency is 20, but I need to find the fx. So I need to take this frequency and multiply it by x. So let's have our fx column here. 1 times 21 is 21. 1 times 22 is 22. 5 times 23. 115. 3 times 24. 72. 8 times 25, I believe is 200. Yep. And 2 times 26 is 52. And so now I add all of these up. So 21, 52 plus 200 plus 72 plus 115 plus 22 plus 21, 482. 482 divided by 20 gives us 24.1. So 24.1 degrees. And that's it. So check us out for the second statistics question video.